Hi everyone, welcome to a new iProcess webcast. My name is Roxana and today we will talk about incorporating ASPICE practices in an agile environment around engineering processes. Let's recap the definitions. Automotive SPICE, it's the automotive industry model for process assessments. It is a framework typically used for process improvements, determining risks in the quality of a specific product release, and as a criterion for supplier selection. Agile is an umbrella for software development methods and techniques such as Scrum, extreme programming, feature-driven development, test-driven development, and scaled agile framework, SAFe. While ASPICE is structured based on the V cycle, there is no requirement that organizations have to convert to the V model to become compliant. In the next exercise, we will explain and map engineering processes from ASPICE to agile practices. In ASPICE, processes are grouped based on the type of activity they engage, and engineering contains two main groups. The System Engineering Group, SIS, which consists of processes addressing the elicitation and management of customer and internal requirements, the definition of system architecture, and the integration and testing at system level. The Software Engineering Process Group, SWE, which consists of software requirements derived from the system requirements, the development of the corresponding software architecture and design, as well as the implementation, integration, and testing of the software. Let's look at the requirements, both system and software. At a high level, ASPICE requires that they are specified, analyzed, structured, prioritized and assigned to releases, consistent and traceable to sources, and communicated to stakeholders. Both functional and non-functional requirements. In Agile, for example, SAFe provides a scalable requirements model to express system behaviors using epics, capabilities, features, stories, non-functional requirements, and more. For system and software architecture, ASPICE requires that they are defined, interfaces and dynamic behavior are described, alternative architectures are considered, architecture is traceable, consistent, and communicated. There is a misconception that agile models don't require architectural design, but model-based system engineering in SAFe, for example, provides a way to explore system elements, structure, behavior, and operational characteristics, evaluate design alternatives, and validate assumptions faster and earlier in the system lifecycle. On the testing side of things, ASPICE requires defining a verification strategy that covers all levels: unit, component software integration and verification, system integration and verification, to execute that strategy and summarize and communicate results. I often see that agile organizations are better with test automation and continuous integration and deployment. The mindset has shifted from testing at the end to execute many tests early, often at multiple levels. In conclusion, following an agile methodology does not prevent you from becoming compliant with ASPICE-based practices. The key is understanding the motivation behind ASPICE and adjusting the practices to your own needs. iProcess helps you understand ASPICE practices and tailor the implementation of those practices to your own organization's agile goals.